So elimination with multiplication. So we're going to take what we did with elimination before, where you either add or subtract the two equations to get one of the variables to fall out. We're going to do this in a way where you can apply this to every single type of system of equations. So if you want to, so long as the x's and the y's line up, every single type of system of equations, so long as the x's, the y's, the equal signs, and the constants line up, you can use just this method for everything, so long as the x's, the y's, the equal signs, and the constants line up. So let me give you an example here. So let's say that we have 3x plus 4y is equal to 54. And then we'll do 5x minus 2y is equal to 38. So with what we've learned so far, bless you, you wouldn't be able to solve this unless you tried to graph it. Because you can't use substitution because you don't have a coefficient of 1 anywhere. You can't use elimination because these are neither equal nor opposite, and these are neither equal nor opposite. So with all the methods I've shown you how to solve stuff, the only one that you could try to use is graphing, and you'd have to solve both of these equations for y, and then graph them to see where they intercept. And you guys hate graphing. Put your hand down on it. We're not doing shadow puppets. Okay. So what you can do instead with elimination with multiplication is choose a variable that you want to eliminate. Okay? So Juju, choose a variable that you want to get rid of. So that's step number 1 in this way. So choose a variable that you want to eliminate. So you want to get rid of y. Okay. Doesn't matter. You can choose a different variable when you start doing this on your own. So choose a variable to eliminate. So Juju chose y, which is totally fine. Once you choose a variable to eliminate, step number 2 is you need to find the LCM. Do you guys remember what LCM stands for?
Length, cat's mouth.
Go ahead, Emily. You were almost there. What was the M? Lowest common multiple. Okay. Lowest common multiple of the coefficients. I've used that word coefficient so many times in the last few weeks. Find the lowest common multiple of the coefficients. So lowest common multiple is often confused with greatest common factor. Lowest common multiple is what the two numbers can multiply to be, not what goes into them. We're not looking for numbers that go into 2 and 4. The greatest common factor of these two would be 2. I'm looking for what they can both multiply to be. So 2 and 4, what can both of these multiply? So they can both multiply to be 8. 4. Which one of them is the lowest common multiple? 4. So we're looking for the lowest common multiple of these two. They can both multiply to be 8. They can multiply to be 16. They can multiply to be 80. Of those numbers I just listed, which one is lowest? 4. So step number 3. I'm going to multiply the entire equation. So multiply the equations to make the coefficients match. To make the coefficients match. So I want to make just these two coefficients, not the x's and not the constants. I'm focusing just on the ones that Juju said she wanted to eliminate. Okay? So she wanted to eliminate the y's, so I don't care about the x's right now, and I don't care about the constants. I just want to eliminate the y's. So I'm going to multiply the entire equation by whatever I need to make the coefficient of y be 4. So in this top equation, what do I have to multiply it by to make the coefficient of y be 4? Okay, I'm going to multiply everything in this equation by 1. In this bottom equation, now I don't care about the sign in this case. What do I have to multiply everything in this equation by to make this number become 4? 2. Again, I don't care about the sign. I'll deal with that sign in just a second. So I'm going to multiply everything in this bottom equation by 2. So my top equation, I'm going to rewrite it just as if I multiplied everything by 1, which would be 3x plus 4y. So nothing changed in the top, equal to 54. But I'm going to rewrite everything in the bottom equation multiplied by 2. So instead of 5x, it's 10x. Instead of minus 2y, it's minus 4y. And instead of being equal to 38, what's it equal to now? 76, right? I think I heard a few people say that. All right, now I've changed the equation. But because I did the same thing to both sides of the equal sign on this bottom equation, it's the same as it was before because I was fair. Since I did the same thing to both sides of the equal sign, I haven't really changed it because I was fair. So long as you do the same thing to both sides, it's fine. All right? Now, if I look here, I've got 3 and 10. Are these equal, opposite, or neither? I've got positive 4 and negative 4. Are these equal, opposite, or neither? They're opposite, right? So now, should I add the two equations or subtract? Add. So I'm going to add the two equations. 3x plus 10x is how many x's? So I got 13x. The y's are going to cancel each other out, equal to, and now I got to do 54 plus 76. So 4 plus 6 is, cool, 130. Divide both sides by 13, yep, and I do get that x equals 10. So divide by 13, x equals 10. Now, okay, thank you, Nathan, for the sound effects. I can take this 10 and I can substitute it back into this equation I made, or I can substitute it back into this equation or this equation that I started with. I can choose any of these equations to substitute it back into. It doesn't matter. So I'm going to choose this one up here to substitute 10 back into for x. Okay? Just because the numbers are smaller. So I'm going to do 5 times 10 minus 2y equal to 38. So 5 times 10 is like a million. Or, oh, 50? That sounds better. Minus 2y equal to 38. Now I got to get that 50 on the other side. So I'm going to subtract it. So minus 50 from both sides. This goes away. I've got negative 2y equal to whatever. Sorry? What's 38 minus 50?
Negative 28.
No.
12.
Thank you. Negative 12. You don't have to be mad about it. It's okay. People make mistakes. Good Lord. So negative 12 divided by negative 2 is what?
6.
Positive 6. Hey, everybody who made that mistake, good job for trying to do it in your head, though. I mean, yeah, nice job. Don't be mad at people. Jeez.
Could you plug it back into the modified equation?
Yeah, absolutely I could. I could have plugged it back in here, and that would have been fine too. I could have done 10 times 10 minus 4y equal to 76, and that would have been fine. So this would have been 100 minus 4y equals 76, and then subtracted 100 from both sides. So negative 4y equal to 76 minus 100 is negative 24. Divide both sides by negative 4, and I still get y equals 6. And the reason that I get the same thing is because this equation and this equation are the same thing, and the reason they're the same thing is because I multiplied both sides of the equal sign by 2. Because if you're fair, if you do the same thing to both sides of the equal sign, it's the same thing. Kind of, sort of? All right. So then as like a coordinate, my answer would be 10, 6. Now, the reason I'm teaching you this is a way that you can avoid having to take an equation in standard form and solve it for y, which is like your least favorite thing I've ever taught you. Kind of, sort of? Okay. It's very true. You don't have to like math. In fact, yeah, you would be in the minority of the entire world if you liked math. So I'm not going to make you guys do an example of this on your own. Instead, I'm just going to pass out the assignment, and we're going to go over part of it together. Yes?
Do you like math?
Of course I do.
So you're
have devoted this many years of my life to trying to convince you guys to like math. Okay, for as much education as I have, Elijah, I could get paid way more doing other things than trying to teach you guys to like math. Like,
I'm sorry about your
so Elijah,
salary.
there's a friend of mine in college who only passed like 3 of his college math classes because I helped him every day in college. Every day. He now makes 4 times as much as I do.
Why do you stand
I'm
for
sorry
that?
you're
Why do you
teaching that.
stand
It's
for
either-
that?
yeah.
I'm sorry you're a teacher.
I'm sorry you're a teacher.
Like, I like being a teacher. I love being a teacher. It's what I wanted to do. So I chose this life for myself. Because I like it.
What's he do?
He works for a website called Project North. He's their webmaster.
They're webmaster.
Okay, so guys, quiet please. So let's go over the first one here. All right. I'll stop recording. So the first one here.